Looking at this function, we're going to see whether it has continuity or, if not, discontinuity. And then if it has discontinuity, what type? Is it a removable discontinuity or a jump discontinuity? Now if I look immediately at the denominator over here, I can see that my denominator is going to create restrictions. If I have restrictions, it means that that denominator may not be equal to 0. So in other words, x may not be equal to minus 2. If this is the case, you can see that f at minus 2 does not exist. In other words, this function is not going to be continuous when x is minus 2. Now that I know that it's not a continuous graph, what type of discontinuity does it have? If I now take a look at f of x and I try and factorize it, I can see that in the numerator I'm going to get x plus 2 and x minus 2. In my denominator, I already have a factor of x plus 2. And so cancelling out my two x plus 2 factors, I can actually see that this can be written as f of x is equal to x minus 2. Now taking a look at the limit as x tends towards minus 2. As this wasn't a split function, I only have to take a look at the expression of x minus 2. If I put minus 2 into this expression, I get a limit of minus 4. In other words, from the left or from the right of this graph, I'm going to arrive at a limit, a height of minus 4 as x approaches minus 2. So because I could get a height, once I had removed the problem, I have a removable discontinuity. Let's check what's going to happen in this example. Remember, if I want to check continuity, and the value that I'm interested here is when x is going to be 2, I find f at 2. Well, when I have f at 2, I'm going to get the answer of 1. So I know that my function exists when x is 2. Let's check and see whether it is continuous. Now remember, if I have continuity, then my limit, both from the left and from the right, must equal to the height that I got at f of 2, in other words, a height of 1. Looking first of all at the limit, as x tends towards 2, from the left, I'm going to substitute into 2x plus 1. The limit as x tends towards 2 from the left is going to be 2 times 2 plus 1. In other words, I reach a height of 5. And now doing the same as x tends towards 2, but from the right. Substituting into 3x minus 1, I'm going to get 3 times 2 minus 1. That is very nicely the same height that I reached as I tended towards the value of x is equal to 2 from the left. In other words, the limit, which is the height that I tended towards from the left or from the right, is going to be a height of 5. As the height is the same, but it is not equal to f at 2, there is a removable discontinuity at x is equal to 2. If I had given you a picture as shown over here and asked you about the continuity, you could have seen that this graph does exist when x is minus 2. The height that I arrive is minus 1. But is this the same as the limit? Remember what I did to find the limit. I ran my finger along my graph coming from the left towards when x is going to be minus 2. And then I ran my finger coming from the right towards when x is going to be minus 2. I definitely arrive at the same height, a height of 3. But as f at minus 2 is not 3, my graph has a removable discontinuity.